Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 5, Graphs of Functions and Equations. So we're starting out with the classwork exploratory challenge exercises 1 through 3. So pause the video, see if you can do these on your own, and then come see how you did after. Okay, so number 1, the distance that Giselle can run is a function of the amount of time she spends running. Giselle runs 3 miles in 21 minutes. Assume she can run at a constant rate. So I have a constant rate C, and then now that we're doing linear equations, that is an M. Write an equation in 2 variables that represents her distance run, y, as a function of the time x she spends running. Okay, so we're given miles, which is distance. Remember, C equals y over x. And in this case, my y is my distance, 3, and my x is my time, 21. So if I take that y over x equals 3 over 21 and cross multiply, I get 21y equals 3x. And then when I divide by 21, I get this to cancel, and I get y equals the reduced value of 1 over 7x. So there's the equation. That means she can run 1 mile in 7 minutes. B says to use the equation that you wrote in part A to determine how many miles Giselle can run in 14 minutes. Remember that y is a function of time x she spends running. X is time. So I'm going to write y equals 1 over 7, and this is my x. So I'm going to substitute in 14, and y equals, think of that as 14 over 1, therefore the 7 and the 14 will cancel, leaving a 2, and 2 times 1 is 2. So y equals the distance in miles. So she can run 2 miles in 14 minutes. Use the equation you wrote in part A to determine how many miles Giselle can run in 28 minutes. So there's my x again. Y over 1/7, y equals 1/7 times 28 over x. I'm sorry, 28 over 1. And then when I simplify, 7 will go into 28 evenly 4 times, so y equals 4 miles. Okay, use the equation you wrote in part A, y equals 1 over 7x, to determine how many miles Giselle can run in 7 minutes. So there's my x again. Y equals 1 over 7 times 7, which I can make 7 over 1. So y equals 7 cancels the 7, 1 cancels the 1, or if you just said 7 times 1 is 7 over 7, 7 over 7 is 1 mile in 7 minutes. E, for a given input x of a function, a time, the matching output of the function y is the distance Giselle ran in that time. Write the inputs and outputs from parts B through D as ordered pairs and plot them as points on the coordinate plane. So I'm going to go back, and B is the point 14, comma, and my answer's 2. There's my point, 14, 2. And this one, it's 28, comma, 4. And in this one, it's 7, comma, 1. So 14, 2, go over 14, up 2 is right here. Okay. And then C was 28, 4. So I go to the right 28, x is 28, y is 4, which is right here. And then finally, part D was 7, comma 1. So that means to go over to 7, which is halfway between 6 and 8, and go up to 1, which is right here. Okay, then I'm going to get my ruler, and I'm going to connect these dots. Okay, so there it is. There is my equation. What do you notice about the points plotted? They are all on the same straight line. Is the function discrete? Okay, keep in mind what discrete means. That means x can only be integers. Our values we substitute in can only be integers, and the answer is no. I can type in 6.1 and I would be right on the line right here. 6.1 is not an integer, therefore this function is not discrete. Now H says use the equation you wrote in part A to determine how many miles Giselle can run in 36 minutes. So it was y equals 1 over 7x, and our time x is 36 minutes. So write your answer as an ordered pair as you did in part E. Include the points on the graph. Is this point placed where you expected it to be? Okay, so we expect it to be on the line. So let's take a look. So when x is 36 and I multiply it, 7 will not go into 36 evenly, so when I do that, I get y equals 36 over 7, which is approximately, is it going to be an approximation or is it going to be equals? Let's put equals first. 7 times 5 is 35, with a remainder of 1. So let's just call that 5 and 1/7. Oops. 5 and 1/7. I saved it and I didn't mean to, but that's okay. 5 and 1/7. All right, so that means when x is 36, y is 5 and 1/7. 36, comma, 5 and 1/7. So that means go over to 36, go up 1, 2, 3, 4, 5, and 1/7 would be just a little bit more, and guess what? We are on that line. So is it where you expected it to be? I would say yes, because I expect it to be on the line, and when I went over 36 and up 5 and 1/7, that point is on the line, and since this is a fraction, that confirms that it is not discrete in part G. I says, assume you use the rule that describes the function to determine how many miles Giselle can run for any given time and wrote each answer on the ordered pair. Where do you think these points would appear on the graph? And they would be on the line. They'd be on the line. Okay. J, what do you think the graph of all input-output pairs would look like? Explain. Okay. Let's see. We know that Giselle runs at a constant rate, so we'd expect that the time she spends running increases, the distance she can run increases at the same rate. And that's what I would think. As time increases, the distance increases. Okay? And K. Connect the points you have graphed to make a line. Select a point on the graph that has an integer coordinates. Verify that that point has an output function that would assign to the input. So I'm going to write y equals 1 over 7x. That's my equation. I'm going to go back, and I kind of got ahead of myself. I drew a line right away because we've been doing it. And they said to find an integer value. So there's one right here. That's the corner of a grid. And that is the point 42, 6. So if I plug that into that equation down here, so now I have the point 42, 6. That means y is 6 when x is 42. So 6 equals, well, 7 goes into 42 6 times, and sure enough, 6 times 1 over 1 is 6. And therefore, it should be on the line. It makes the equation true. I says sketch the graph of the equation y equals 1/7 x using the same coordinate plane in part E. What do you notice about the graph of the input pairs that describes Giselle's constant rate of running and the graph of the equation y equals 1/7 x? Well, we've already done that. Okay. And there's our equation. Now, of course, I didn't continue beyond there because there's no such thing as negative time, and we can't run in a negative distance. Okay, distance can't be negative either. So this point, this is really a ray and not a line. It's a linear equation with a restriction of 0. You cannot plug in negatives in this real world scenario. Okay, just be aware of that. Number 2, sketch the graph of the equation y equals x squared for positive values of x. Organize your work using the table below and answer the questions as follows. So before I start this, I'm going to focus on this equation. And I see that the x has an exponent of 2. And if it is linear, then x can only have exponents of 0 or 1. Otherwise, it is not a line. So that is what I need to keep in mind here. So when I plug in x, I should find my y. So 0 squared, this would mean 0 times 0, and that is 0. And if I plug in 1, 1 times 1 is 1. And if I substitute in 2 here, that means 2 times 2, 2 squared, 4. 3 squared is 3 times 3, which is 9. 4, plugged in here, 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, which is 25. And the reason I'm doing this is because a lot of students at the beginning get confused with squares and they think it's 5. Like if I plug in the 6 times 2. Well, 6 times 2 is 12. And 6 times itself, which is what squaring means, repeated multiplication, is 6 times 6, which is 36, not 12. It doesn't mean times 2, it means times itself. Okay, so there's my points. So now it says to graph the points on the coordinate plane. So I'm going to plot 0, 0. So the way I've got this zoomed, I can't see the whole thing, but that's okay. 0, 0, and now I have 1, 1. Now I can see it all. So 1, 1, be careful. 1, 1, this is going in 2, so 1 is only halfway this way. 1, 1 is right here. The point 2, comma 4 is right here. The point 3, comma 9 is halfway between 8 and 9, or here. Okay, it looks like a straight line here, but now something's happening. And if I go to 4, I'm going up to 16, which is here. And 5, 25 is halfway between 24 and 26. And then finally 6, comma 36 is here. So there's the ordered pairs plotted on the graph. So if I were to draw a straight line, I'm not going to, but I'm just bringing my ruler down to indicate where that straight line would be. And I put it at the origin, like so, and rotated it up to that first point, then my line would be here. Obviously, these points are not on that line. So now if I take this line and rotate it until I get it so that 2 points are on the line, like this. Okay, so now those 2 points are on the line, but notice this point and this point are not, and then these points are not, and if that continues that way, so this is obviously not a linear function, and that's what I wanted to point out to you. Okay, so there's the ordered pairs plotted. B says, what shape does the graph of the points appear to take? Okay, and obviously it's not a straight line, so it appears to curve. Let's call it a curve. It appears to be a curve. Is the equation a linear equation? No, it is not a straight line. Okay, D, consider the function that assigns to each square of the side lengths S units its area A square units. Write an equation to describe this function. Okay, consider the function that assigns each square of sides length S. So what they're saying is we have a square whose side lengths are S units, its area A square units. Okay, so keep in mind the area of a rectangle or a square is length times width. But in this situation, we're calling the length S and the width S for sides. So the area would equal S times S. Well, then therefore the area is S squared. E. What do you think the graph of all input-output pairs S, comma A of the function would look like? Explain. So if I graphed the input-output pairs of S comma A, so in other words, the length of the sides comma the area, what would the function look like? Okay, and I think it would look like the same as y equals x squared, which is what we graphed on the last page. Because A would be our area, and our x would be the length of our sides. So we're squaring the sides to get the area of the square. And F, use the function you wrote in part D, A equals S squared, to determine the area of a square with a side length of 2.5 units. So A would equal, substitute in 2.5 and square it. Write the input and output as an ordered pair. So A equals, well, I know from my multiplication tables that 25 times 25 is 625, but this has decimal places, so it's 2.5 times 2.5 is 6.25 units squared. Okay, does this point appear to belong to the graph of y equals x squared? We have to now write it as an ordered pair. So we plugged in 2.5 for x, and when I squared it, I got a y of 6.25. So this is the point. So 2.5 comma 6.25. If I go back to my graph and I go over 2.5, then I should go up 2, 4, 6, and 0.25 should be right here. And if I did draw a curve like so, okay, let's see if I can do better. Draw a curve, see how it's going through each point? Okay, and if I keep going up, this is a little difficult on this pad, but you get the idea. That point that we just graphed, 2.56.25 is right there. Okay. So does that appear to belong to that graph? And I'd say yes, it does. Number 3. The number of devices a particular manufacturing company can produce is a function of the number of hours spent making that device. On average, 4 devices are produced each hour. Assume that devices are produced at a constant rate. Write an equation in 2 variables that describes the number of devices y as a function of the time x. So you put y over x equals, and y is time. So we put 4, or not time, x is time, y is devices, and hours is time. So we want 4 devices per hour. When I cross multiply, I get 1y, or simply y equals 4x. So there's my equation. Use the equation you wrote in part A, so let's write that here, to determine how many devices are produced in 8 hours. So y equals 4 devices per hour is 8, so y would equal 32 devices. Use the equation you wrote in part A to determine how many devices a product can produce in 6 hours. That is x. So therefore y equals 24 devices in 6 hours. So I should be labeling these, I suppose. These are x's, and we're trying to find y. And then use the equation you wrote in part A again to determine how many devices a company produces in 4 hours. So that would be 4 times 4. So therefore y equals 16 devices. Okay. So E says the input of the function x is time, and the output function y is the number of devices produced. Write the inputs and outputs from parts B through D as ordered pairs and plot them on the coordinate plane. So we're going to do B through D. So this is ordered pairs. So now I'm going to plug in x and get my y. Substitute in an x, and we got a y. And substitute in an x, and we got a y. So we're going to plot those points, 8, 32. So I go over to 8, and all the way up here to 32, which is right here. That is 8 hours, 32 devices. My second one was 624. So I go over to 6 and way up to 24, which is right here. Okay, and then I go back one, and I'm going to do 416. So I'm going to go over 4 up to 16, and then what shape does the graph of the points appear to take? And I would say they appear to be linear, and I will verify that with a ruler. This time I will not draw it until they tell me to, but I'm going to put my ruler on one point, rotate it up through the others, and you do see that they will all land on the ruler. Off just a little bit. There we go. Something like that. So they do appear to be linear. They appear to take the shape of a line. Is the function discrete? Well, what is x in this situation? Time. So I would say no, because I could say 3 1/2 hours. How many devices? So this is my x. It is a fraction. It is not an integer, therefore it is not discrete. And in discrete functions, we can only substitute in integers, or whole numbers, I should say. H, use the equation you wrote in part A to determine how many devices are produced in an hour and a half. So there you go. That's why it's not discrete. So what was our equation? We got y equals 4x. I had forgotten it, so I need to write y equals 4x. And then we want to know 1.5 hours, which is my time x. So y equals 4 times 1.5. So y equals 6 devices. Write your answer as an ordered pair, 1.5, comma 6. Include the point on your graph. Go over 1.5, up 6. It's right here. If I move my ruler down, all those points are on the ruler's edge, so that's still on the same straight line. Okay. Is the point in a place where you expected it to be? Yes. It's on the line. I, assume you use the equation described in the function to determine how many devices are produced for any given time and wrote each answer as an ordered pair. Where would these points appear on the graph? And they'd appear on the line. Y equals 4x. I should actually say that. On the line, y equals 4x. Okay. What do you think the graph of all possible input-output pairs will look like? Explain. Okay. Well, it'd be a bunch of points on that line. So it's a set of points on the same line. Okay. It says connect the points you have graphed to make a line. Select a point on the graph that has integer coordinates. Verify that this point has the same input-output of the equation to make it true is basically what they're saying. So now I'm going to connect those dots. So I didn't do it ahead of time like I did last time. Oops. Let's try that again. Let's start up here. And there we go. Okay, so there's my line, and I'm going to call that y equals 4x, label it, and all those points. Now it says to choose a point on the line, so how about this one here? That is the point 3, 12. Go back to that question and write down that point 3, 12. I want to prove that that is true for the equation y equals 4x. My y is 12. My x is 3. 12 times equals 4 times 3, which is 12, and it makes the equation true, so it is on the line. L, sketch the graph of the equation y equals 4x using the same coordinate plane. In part E, what do you notice about the graph of the input-output pairs that describe the company's constant rate of producing devices, the graph of equation y equals 4x. So what they're saying is graph y equals 4x, so you plot a point. My intercept is 0. Slope of 4 means go up 4 over 1 right there. If I graphed a line going through those 2 points I just created, as you can see, it would be the same line. So let me change to red, and now I'm going to graph from here to here through the y-intercept of 0 and a slope of 4, or a rate of change of 4 up 4 over 1, and as you can see, the lines coincide. So there's only one line you can draw for that function. So that's L. Okay, exploratory challenges exercise 4. Number 4, examine the 3 graphs below. Which, if any, could represent the graph of a function? Explain why or why not for each graph. Okay, so let me get my ruler. And I'm going to see if they all land on the same line. So I'm going to do this. Draw a line. So every single point on this graph is on this straight line. And I can find the equation of this line because it's y equals mx plus b, and my b is 3, and my slope, I went down 1, right 2. So it's negative 1/2 x plus 3. Okay? So is this a graph of a function? And the answer is yes. Okay, remember, if you have a function, you can only get one y value for each x you plug in. So I plug in 2, I got a 2. I can't get any other number on this vertical line. And that's what we're leading up to here. So now if I graph this, I'm not going to use my ruler because obviously it's not a straight line, but if I just connect these dots from left to right, and I go over here, something's happening right there. And then if I come down like this and continue, it could be a function. It just doesn't have to be a straight line to be a function. This could have been a function except for this point right here and this point right here are the points 6, 4, and this is the point 6, 6. So if I have the same x's, I cannot get 2 different y's. Therefore, this is not a function for that reason. Okay? By definition, a function is when you can substitute in an x and get a unique y. So 6 is not the same as 4. Okay, so that is not a function. And we're going to call this something. So on a graph, if I can draw a vertical line from one point to the other, so since I can draw a vertical line here, okay, that's called a vertical line test. If there are 2 points on one vertical line, then it is not a function. So if I move this vertical line around, as you can see, there's only 1 point on this vertical line at any given time. 1 point, 1 point. So if I stop my function right here and didn't count these 2 points, then this would be a function all the way to this point. But as soon as I get here, I see that there's 2 points on that line. It is no longer a function. If I continue, now there's only 1 point, only 1 point, only 1 point, only 1 point. So other than this right here, this appeared to be a function, but then when you find 2 points that are on the same vertical line, all bets are off. This is no longer a function. Okay, graph 3. So again, I'm going to draw a vertical line. That's how we're going to check these now. So I'm going to draw a vertical line like so. And then I'm going to move that vertical line around. So if I put this line here, and as you can see, this point is the only point on that vertical line. Now if I move that line here, again, this point here is the only point on that line. Move it here, still just 1 point, still just 1 point, still just 1 point, 1 point, 1 point. So for every x, so I'm going to give you the values now, this is the point -3, -9. This is the point -2, -4. This is the point -1, -1. This is the origin 0, 0. This is the point 1, -1, and this is the point 2, -4, and then finally 3, -9. So now if I do it with points, notice what's happening here. Okay, as you can see, the x's are not the same. The y's are, that's okay. But I cannot have one x going to two different y's. But I can have one same y going to two different x's, that's okay. Because if I determine the slope of this vertical line, it's undefined, okay? But if I rotate this 90 degrees and then put it on this line right here, now those 2 points are on that line, that's okay. That is a slope of 0. I can divide 0 by a number. I cannot divide a number by 0, or it's undefined. So this is a function. Okay, that is the end of lesson 5. Review the lesson summary and go do your problem set.